Hi Year 12s, it's Mr. Lim here again, and this is a video about the identification of organics, and we're just going to be identifying some of the organics that we've learned so far. Alright, so these are the ones that we're going to do. They're not all of them, alright, but these are the ones that we are going to learn how to identify via some chemical tests. Okay, so let's have a look. So these things here are what we are going to identify, and so generally we are looking for the properties to distinguish them. Okay, and so these are the properties that we've discussed already. So in our videos about the various substances, we've gone through their ability to reduce, their ability to oxidize, really acidic nature right now, but later on we'll get into basic molecules and the observations of products formed. Okay, so each of these properties can be assessed by a chemical test where the chemical reaction occurs. Physical properties can be used, but they're not as good. So physical properties like melting and boiling points can be used, but they're not as definitive because, well, other things also. So I guess generally what you're looking for is multiple pieces of evidence to identify something. So like one chemical test that does this, one chemical test that does that, so on and so forth. All right. So let's start with the first one, ability to undergo reduction. So you need to know what's the chemical test to be able to see whether something will undergo reduction. So what do? You add a reducing agent to it. Okay, the typical reducing agents are sodium metal or potassium metal. Okay, and so hopefully you've seen what happens when you add sodium metal or potassium metal to water. It will fizz, it will bubble. Sometimes it can catch on fire and produce a characteristic purple or orange fire. All right, so that's a reducing agent, and this will identify all carboxylic acids and alcohols, or it's not identifying it all. This reaction will occur with our alcohols and carboxylic acids. All right, the hydrogen attached. Okay, so the hydrogen attached on the OH group or the COOH group, that hydrogen there, will reduce to hydrogen gas, so the bubbles of a clear colorless gas will be formed. Okay. Alcohols can be differentiated by the speed at which they produce bubbles, but it technically isn't a chemical test. So in general, we have the primary alcohols react the fastest, the secondary which react second fast, and then tertiary which react the slowest. Okay, so you add the sodium metal to it, you look for bubbles if they start to form. If bubbles start to form, then it's undergoing reduction if you know that it's going to be one of the alcohols or carboxylic acids, one of those things that we listed out at the beginning. All right, let's look at the next one. Ability to undergo oxidation. Okay, so what do? You add a oxidizing agent with a strong, which is a self-indicator. Okay, so we went through a little bit of this in the redox videos. So you're looking for something that will change color itself when it undergoes reduction. Okay, because remember, oxidizing agents undergo reduction. You want something that changes color. So you've got potassium permanganate, which goes from purple to colorless effectively, and sodium dichromate, which goes from orange to green. Okay, and remember, it is the permanganate that does the change in color and the dichromate, not the sodium and the potassium. Okay, so you have those half equations on the back of the data sheet as well. Okay, this will oxidize primary alcohols, secondary alcohols, and aldehydes. So if you need to separate out those from others, you can via the ability to oxidize. Okay, change of colors, that's what we said. Ensure that you see the appropriate color change. The oxidizing agent should always be the limiting reagent to ensure the color change occurs. Okay, because if you add too much of the self-indicating substance, then it may not all change, and then it will stay the color that it originally started at. Okay, so you might expect to see potassium permanganate change color from purple to colorless, but if you add too much permanganate, you're not going to go from purple to colorless, because there'll still be some purple permanganate left because it's in excess. So only add a little bit of it. Okay, and then don't forget to have that, even using the standard reduction potential table, that these reactions need acids to occur. So you need a H plus ion. So generally we add a little bit of concentrated sulfuric acid beforehand just to make sure that it has enough H plus ions to react. Okay. Then we can look at acidic or basic nature. There's a couple of ways we can do that. You can dump in an indicator or use a pH meter. This will identify carboxylic acids, or carboxylic acids will be acidic and everything else will not. You form hydronium ions, which lowers pH, that makes sense. or you can add some carbonate solution or solid to the solution. All right, so carbonate, like sodium carbonate or something like that. What will happen when you add a carbonate to a acid? It'll form bubbles of carbon dioxide. And then you can see those bubbles and be like, yes, that's what it is. Or that's at least that is acidic in nature. Okay. And then finally, you can look at some of the observations of products forms. Now, this is not the most ideal because when you mix two things together for a reaction and then you want to look at the product that is formed, you've got a whole bunch of stuff. Okay, so here's your beaker, here's your original reactant. Then you add the reactant that you are using to test, and then ideally that substance there changes to something else. But if you've got this substance here which has changed to something else, you've also got it mixed with the original reactant. So the original reactant can sometimes also react with stuff, so it's not ideal in the way to test, but it is possible if you've got no other choice. Okay, so you can test them. Alternatively, if you know how to separate those two substances, then you can take that product and then test it as well. So it's generally used for only the primary and secondary alcohols, which have the same reaction patterns for the other things before. Primary alcohols form carboxylic acids after oxidation, hopefully you've memorized that, while secondary alcohols form ketones, and then carboxylic acids have different reactivities to ketones. Okay, so if you use a non-acidic oxidizing agent, so those are the ones that we didn't talk about last lesson, or the last slide, okay, you can use hydrogen peroxide if you want. You can test the pH of the final solution. If you test the pH of the final solution and you see that it's acidic, then it's the carboxylic acid, whilst if it's neutral, it's the ketones. However, it's not that great a test. Alternatively, you can react the carboxylic acid with an alcohol to form an ester, which has a characteristic fruity smell, and we'll be learning more about esters later on. Okay, so this table summarizes all of that we've just talked about there. Okay, and ideally you would memorize this table. So you see that primary alcohols can reduce and can oxidize, but they're not acidic in nature, and so on and so forth for all the others. Okay, and so you see that the only two that match are these two here, the primary and secondary alcohols. If you do these three tests to all the other substances, hopefully they'll react in the way that they're supposed to, and therefore you'll be able to identify them from each other. All right, because each of them has a unique pattern, or each of these five have a unique pattern. And so therefore you'll be able to look at them and be like, oh, okay, then whatever that pattern is, it matches what I did in the experiment, and therefore you can identify it. Also, you can also talk about like working out a way to differentiate between certain combinations of substances. So, for example, if you have three unknown organics and you don't know which one's which, all right, but you know that one of them is a primary alcohol, a ketone, and a carboxylic acid. So a primary alcohol, a ketone, and a carboxylic acid. So you might do a couple of chemical tests. First of all, you might do a chemical test. Well, actually, first of all, you really should just do all three of them and then just look at the pattern. But if you wanted to do a couple of tests to save some time, you could first of all look at acidic nature. Okay, the acidic nature, you see that primary alcohols are no, ketones are no, but carboxylic acids are a yes. So that will differentiate them, and you will eliminate the carboxylic acids. All right, then you could do a test for whether it can oxidize. All right. And then you see that primary alcohols, yes it will, ketones, no it won't, so therefore you've identified the ketones and the primary alcohols. Okay, but it's important to memorize those tests. Acidic nature, so you just do a pH test. Once you do a pH test, you can add some acidified permanganate or sodium dichromate, and then you can see what happens there, whether it changes color or not. Okay, here's another one. Secondary alcohols, aldehydes, and ketones. So what you can have a think about what those things will do. Pause the video and try it. And then tertiary alcohols, aldehydes, and carboxylic acids. All right, you can have a look at those patterns and work out what type of tests to do. Okay, this video is gone for too long anyway. Adios.